Hi, I'm George Self. This video is one in a series designed to help with the R labs for BASV316 Introductory Methods of Analysis. This is Lab 5, Frequency Table. A frequency table is used to display the frequency or the count, the number of times a particular item shows up in a vector. Frequency tables are fairly easy to generate in R. Well, here's an example of a frequency table using the MT cars data frame. Those are Motor Trend cars, some information about various cars from the Motor Trend magazine. You can see here I have a frequency table that lists the number of cylinders for cars. So 11 cars had 4 cylinders, 7 cars had 6 cylinders, and 14 cars had 8 cylinders. To create a frequency table, we use this command table. And I can see in the MT car data frame that 15 cars had 3 forward gears, 12 cars had 4 gears, and 5 cars had 5 gears. As usual, I want to just copy this particular command and paste it in here because that way it's easier to do and it avoids typos. For feed into chick weights, data frame, feed, and run that. And there's my data table, or frequency table rather. And again, I will copy that because I know it works. And the deliverable for frequency table is the frequency of, in the cafe data frame, for meal. How many people ate breakfast, how many people ate dinner, and so forth. You can see that lunch is the most popular meal at our cafe. Margins does nothing more than add the total count to to a frequency table. You can see here in the MT cars data frame, all it did was add 11 and 7 and 14 and get 32. Margins is pretty easy to do. The command is add margins to the table. We run this, and you can see here that we get 32 cars total. I'm going to copy this command because it's getting a little bit longer than most of the others we've used so far. Paste it in here. And now we need the margins for chick weights and feed. Run this. And we see there were a total of 71 chickens in our experiment. I want to copy this because I know it works. And paste it in here. I want a frequency table for cafe, data frame, and meal. Run that. And I see we had a total of 375 diners in our restaurant. A prop table gives proportions, so instead of just numbers of people or numbers of cars, it will give a proportion or percentage, because a lot of times researchers want percentages instead of raw numbers. This command is a little more involved than the others because you have to multiply your percentages by 100. The demo table that I'm doing here actually has 2 different prop tables. In the first one, we do not multiply by 100. In the second one, we do, so that you can see the difference. Let me run this. And you can see the first time the MT cars gear, you can see that was 0.46 proportion of all of the cars had 3 gears. But if we multiply that by 100, we see it's 46%. To be honest, most people are a little more comfortable with percentages instead of just the proportions. Now I know that this particular command works all right, so I'm going to copy it and come down here, paste it in. In this case, we're using the chick weights data frame, and I want the feed, and we're going to do a prop table for that. So if I run that, I can see that, for instance, 16.9% of our chickens were eating casein feed, whatever that is. If I copy this, because I know that it works, I can now create a prop table to submit for grade, and this would be the cafe data frame, and I want the meal, and I run that, and I see that about 28.8% of our diners had dinner. A crosstab is sometimes called a contingency table or a pivot table. It's what you may be used to if you've worked much with Excel. This is a crosstab from the MT cars data frame. You can see, for instance, the number of cylinders across the top, 4, 6, 8-cylinder cars. The number of gears down the left side, 3, 4, and 5 forward gears. So I see that, for instance, one car had 4 cylinders and 3 gears. Here's a second example from another data frame, ESOF, which has to do with esophageal cancer. You can see that the number of cases by age group, and this particular crosstab shows an interesting pattern where there are no cases for younger people, but as the age goes up, the number of cases goes up until you get up to 75 plus, and then the number of cases drops. That's probably not because people are not getting cancer at that age, but frankly, there are probably just not as many people who are 75 years and older. At any rate, this is a crosstab. Here's a demonstration of crosstab, and you'll see again we're using the MT cars data frame. Because I know this works, I'm going to just copy this out here and paste it in here. I do want to point out that in the crosstab command, let me see, that the tilde is used to separate 2 parts of the formula. The part before the tilde are the data values to be acted upon, and the second part are the grouping vectors. Notice here that gears comes first, and that's what goes down the left column. Cylinders come second, it's what goes across the top. I'll paste that in there. I can get rid of all of this. For tobacco group and alcohol group in the esophageal data frame, and it doesn't say whether you want tobacco to be across the top or down the side, so I'll just put it first. Tobacco group, a plus sign, and then ESOPH and alcohol group. Let's see if this works. Oops, I had a typo. I should have looked at that. ESOPH. Try that. And there we go. This is the crosstab that we were looking for. And again, I know that this works, so I'm going to just copy this. Well, there was a typo there, but that's all right. I'm going to retype that part anyway. Paste that. Get rid of all of that. Food and service. So cafe, dollar food, plus cafe, dollar service. And run this. And there's our crosstab. A multi-dimensional crosstab. Well, crosstabs aren't just two dimensions, just width and length. You can actually do a crosstab of three variables. For example, the MT car's data frame. I have here a crosstab of cylinder, gear, and AM, that's manual or automatic transmission. Now the third value here will be the one that's the major grouping value. So notice we have AM, automatic transmission is 0, that means no. That's a manual transmission. Automatic transmission, yes, that means it's a manual transmission. And so I may have just said that backwards. I'll have to review the tape, but I do note here AM0, which is a code for automatic transmissions. So the automatic transmissions come first. With automatic transmission cars, 3-cylinder cars, 3-gear cars and 4 cylinders, one car had an automatic transmission. The demonstration has two different examples of a multi-dimensional crosstab. Let me just run this. And I will scroll up here just a little bit. The count of carburetors and cylinders by engine type. And you can see the engine type, that's V8 or straight carburetors and cylinders. The data is the MT car's data frame. And you can see here for a VS is 0, that's a V8 or straight, and a VS is 1. Well, let's actually do one of these. I will copy this out and scroll down here and paste it in here. I need a crosstab for the esophageal data frame, ESOPH, and I need tobacco group plus alcohol group by age group, and run that. And there we go. So here for age of 65 to 74, you can see the various amounts of alcohol and tobacco that people use and the number of cases of esophageal cancer that we came up with. Well, let me copy this because it's a fairly long command. And the deliverable here, data frame is cafe, and we need food and service by sex, and run that, and there we go. So you would copy and paste all of this table into your deliverable for this lab. Next are calculated crosstabs. Oftentimes we don't want a count of items, how many cars had 2 cylinders or something. Instead, we want to calculate a mean or a median or something like that. And the command for that is aggregate. So we're going to aggregate in this case. We're going to calculate the temperatures by month, and you can see the month here is 5, 6, 7, 8, and 9. The data is the air quality data frame. Well, this is a data frame that measured the air quality in New York City over a 5-month period. And the function is mean, the mean temperature for New York City over these 5 months. Here's another example from the Motor Trend Cars data frame. You can see we're going to calculate the mean of the horsepower by gear and cylinders. So 3 gears and 4 cylinder cars, the mean horsepower is 97. Our demonstration has 2 examples of generating a calculated crosstab. Let me just run that. In this second example, the more complicated example, I'm going to calculate the displacement, the engine displacement by cylinder and gear from the empty car's data frame using a function of mean. Let me copy this, and our guided practice, I will paste that in. I need the mean yield. Well, first let me change the data frame here. This is NPK data frame. I see it's the mean yield, so the function mean is correct. I want the mean yield, Y-I-E-L-D, for N plus P plus K. This is I made a typo there. I need to make this N. This is an experiment where a farmer applied nitrogen, phosphorus, and potassium to a field to see what the yield would be. So let's run this and see what we get. I see that the yield here, the mean yield, and I'm just kind of looking down through there. It looks like the largest mean yield was where we applied nitrogen, but no phosphorus or potassium. I'm going to copy this because I know it works. And here's my deliverable. I'll paste that. I still want the mean, but in this case I'm going to use the cafe data frame. And I want the tip when we are doing food and service. And run that. And there we go. So this gives me the mean tip. If someone rated food and service as 1, the mean tip was $3.62. And the highest tip here was if someone rated the food at 4 and the service as 5, the mean tip was $5.25. Now rounding, all along I've told you that it's fine to round your results to 2 decimal places. Well, of course, R can round also. And this part of the lab, I'll show you how to use rounding in R. There's a very important note here. In fact, 2 very important notes. First, even if the displayed value is rounded to 2 decimal places or 3 decimal places or whatever, R still uses the full decimal number to do calculations. So rounding only affects what you see. It doesn't change anything about the calculations that's going on behind the scenes. Probably a more important note is to notice that R uses what's sometimes called banker's rounding. That is, it always rounds to the nearest even digit. It's a little different than you may have learned in elementary school. For example, 2.5 is actually rounded down to 2 because 2 is an even number. But 3.5 is rounded up to 4 because 4 is an even number. And using this so-called banker's rounding means that the result will always be even. Now, there are lots of reasons why that is used by accountants and bankers and such. You can look that up for yourself. Google banker's rounding and you'll get lots of information on it. But you should understand that R uses banker's rounding. Here's a demonstration of rounding. And you'll notice that, for instance, we're rounding here to 3 digits. You'll notice that the end is always an even number. Here we're rounding to 2 digits, and you'll notice this last digit is always even. Okay. So here we're going to round, and I'm just going to copy this because this is a big old long command. Our guided practice, paste that in. We want a calculated crosstab of age rounded to 2 decimal places for case, induced, and spontaneous in the invert data frame. All right, well, I'm going to unpack that. We're going to use just 2 decimal places, so I'll change that to 2. We do want the age rounded to 2 decimal places in the invert data frame. Aggregate the mean, so the mean is what we're after. I know we want the invert data frame, and we're going to aggregate the age for case and induced. Well, that was pretty complicated. Let me run that. And oops, it looks like I have a problem in my formula. So let me go back and see if I can figure out what I did there. For the crosstab, it's age, induced, then the 3 grouping variables. Oh, and spontaneous. I left out spontaneous. Let me run that and see if that works. Much better. So here's our big old long command. I'll copy that because now we're going to practice this and paste that in. And it's time to unpack everything here. I want to round to 2 decimal places. That's good. I'm going to create the mean is the function. The data frame here is going to be cafe. And I want to calculate the mean tip. And the variables I'm going to use are food and service. Run that. And there we go. And this is what I would submit with my deliverable. That's it for this lab. It is a longer lab, but it covers a lot of ground. Good luck with it. If you run into problems, please let me know. I'll be glad to help. I'll be seeing you online.